Let's take a look at a couple more examples using some of the ideas with distance and slope and midpoints and so forth. This one says the vertices of a parallelogram are A at negative 2, 2, B at 4, 6, C at 6, 3, and D at 0, negative 1. And you can see I've graphed those four. Is ABCD a rhombus, and explain. First, let's go ahead and connect all our corners so we can see what our shape looks like here. So I'll connect A to B here, try and do it as straight as I can. Connect B to C, connect D to C, and then connect A to D. So there's our shape. And it first asked, is it a rhombus? Now, if I look at this, I don't think it's a rhombus, because a rhombus should have all four sides equal length. But let's go ahead and verify. Let's prove that this is definitely not a rhombus by showing that all four sides are not the same length. So I'm going to find the length of, first, AB. All right, so the length of AB is going to be the square root of the change in x's and the change in y's squared and added together. So to go from A to B, the change in my x coordinates is going to be a total of 6. I can see that A has an x-coordinate of negative 2, and B has an x-coordinate of positive 4. To get from negative 2 to 4, I think of it as first I have to go from negative 2 to 0. We can look at that on the number line here. From negative 2 to 0 is 2 units, and then I got to go 4 more units to get to positive 4 for a total change of 6. So my delta x is going to be 6. So I'm going to do 6 squared plus, and now I need to find my delta y. The y's are 2 and 6, so the difference between 2 and 6 is 4. So my delta y squared is going to say 4 squared, and so that's going to be the square root of 36 plus 16, which is the square root of 52. Now that is the length of AB. Let's find the length of BC here. BC, my x coordinates are 4 and 6. That's a difference of 2, so we'll have 2 squared. The y coordinates for B and C are 6 and 3, so that's a difference of 3. So I'll have 3 squared. So this is the square root of 4 plus 9, which is the square root of 13. Now I can actually stop there. If I'm just supposed to ask if this is a rhombus, I've already shown that it has two sides that are different length. And I think that's enough to say, nope, this is not a rhombus, because not all sides are congruent. Say, no, not all sides are congruent. Sides are congruent. The next part says, is it a rectangle? Now, in order for it to be a rectangle, I can think of this two ways. I can either show that all four angles are 90 degrees, which would involve finding the slopes of all four sides, and then maybe taking a look and seeing if those slopes were opposite reciprocals of one another, here between these two, here between these two, here between these two, and then again here between these two. I'd have to find all four slopes and then compare them to show that each corner is made up of two lines with opposite reciprocal slopes. Or I can use the other method of proving that a quadrilateral is a rectangle, which is to show that their diagonals are congruent. We learned a few videos ago that if the diagonals of a quadrilateral are congruent, it has to be a rectangle. I think that sounds easier, finding the distance from A to C and finding the distance from B to D. So I'm going to go that route. First, I'm going to find the distance from A to C. So I look at A and I look at C, and I notice that their x-coordinates are negative 2 and positive 6. That's a difference of 8. So I'll have 8 squared there. Then I'll look at the y-coordinates for A and C, 2 and 3. That's only a difference of 1. So my distance from A to C is the square root of 8 squared plus 1 squared, which is the square root of 64 plus 1, which is the square root of 65. So from A over to C is 65. Let me draw that diagonal in. I'll draw it in another color. So that length is 65 right there. Now we're going to check the length of BD. So from B down to D. Let me draw that in. And I'm going to use the same formula I used. Oh, not BC, sorry. Let me erase that. That should be BD. I'm going to use that same formula. I'm going to look at, for B and D, the x coordinates are 4 and 0. So that's going to be a difference of 4, so 4 squared. The y coordinates are 6 and -1. 6 and -1 have a difference of 7. So the change in the y's is 7. So that's the square root of 16 plus 49, which is also going to be square root 65. So since the diagonals here are the same lengths, I can say yes, because diagonals are congruent. It must be a rectangle because the diagonals are congruent. Now this next example gives us another quadrilateral and asks, is it a kite, a trapezoid, or neither? So for it to be a kite, I can either look at all 4 sides and compare them in terms of their lengths. And I could say, well, if it has 2 sides that are congruent and consecutive, so that would mean maybe that if this one and this one are congruent as well as this one and this one, then that would make it a kite. A trapezoid has to have 1 pair of parallel sides. So I could look and see maybe if these 2 are parallel or if these 2 are parallel. Now let's start with that idea. I can actually just look at this and tell that neither pair of opposite sides are parallel, because this side of the shape is a vertical line, which would have undefined slope, and this one definitely does not have undefined slope. It is not a vertical line. So these 2 are not parallel. This line, this segment, is a horizontal line with 0 slope, but the side across from it has this positive slope going up like this. So I'm going to cross off trapezoid. I'm going to say it's not a trapezoid because neither pair of opposite sides are congruent. I'm sorry, are parallel, not congruent. Now the other option is to prove that it's maybe a kite. So I can look and see if this side and this side are congruent, which actually it's kind of easy to see that they are. From here down to here is just a drop of 4 units, right? So that side has 4 for a length, and then this side also has 4 because I'm moving straight over 4 units. So that side is 4. So now let's see if RQ and RS are congruent. So RQ, let's find that length. From R to Q is the difference in the x coordinates is 5 because this is 2 and this is 7. So I'll have a 5 squared there. The difference in the y's is 1 because this y coordinate is 5 and this y coordinate is 6. So I'll have a 1 squared there. So that's going to be the square root of 25 plus 1, which is square root 26. And I'll go ahead and add that to my picture that the length of RQ is square root 26. Now let's do RS. The difference in the x's is 1 because this x is 7 and this x coordinate is 6. So I'll have 1 squared at the beginning of my distance calculation. The y's have a difference of 5, 6 and 1. So this again is going to be the square root of 1 plus 25, which is the square root of 26. So this is a kite. I can see that it's a kite because it has two pairs of congruent consecutive sides. And that makes it a kite. Finally, we have this question with another quadrilateral put on a coordinate plane. So W is at 5, 4, X is at 2, 9, Y is at 9, 9, and Z is at 8, 4. And the first thing we have to do is find the perimeter. Now I'm going to go ahead and draw in my shape here. So I'll connect X to Y, I'll connect Y down to Z, connect W to Z, and then connect X to W. So there's my shape. And I got to find the perimeter of it, which means I need to find the length of each side and then add all those together. So let's start with XY. XY, the segment itself is a horizontal segment. So that tells me I think I can just count the blocks, if you will, to figure out how long that is. To get from X to Y, I'm going 1, 2, 3, 4, 5, 6, 7 units. So that is going to have a length of 7. WZ is also going to be an easy one because it is also a horizontal segment. It's only 3 units long, right? 1, 2, 3. So I got a 7 up here, I got a 3 down here. Now the other two are a little bit trickier. So let's go with xw. Let's find that. So I'm going to be using my distance formula, comparing x and w. Their x's, their x coordinates are different by 3, 5, and 2. So I'll put 3 squared here. Their y coordinates are different by 5, 4, and 9. That's a difference of 5. So I'll put 5 squared. And then if I simplify that, that's going to be the square root of 9 plus 25, which is going to give me square root 34. Right? This is a 9, this is a 25. So 9 plus 5 is, or 9 plus 25 is 34. So that is the square root of 34. And then yz, let's do that distance right now. Yz is going to be the square root of, let's see here. From y to z, the x's are different by 1. So that's going to say 1 squared. And the y's are different by 5, 9 and 4. So the square root of 1 squared plus 5 squared is the square root of 26. Now, when I add all these together, if I want to give an exact answer, it's going to look a little bit weird. My exact answer would say 7 plus 3 plus square root 34 plus square root 26. And really the only thing I can do here is add the 7 and the 3 together. I can't actually add the 34 and the 26. The rules of square roots just don't work like that. These are almost like not like terms, if you will. So if I wanted to give an exact answer, it would say 10 plus square root 34 plus square root 26. So maybe what we'll do is we'll go ahead and give an answer rounded to the nearest tenth. So I'm going to grab my calculator. I'm going to do 10 plus the square root of 34 plus the square root of 26. And I'll get an answer that's about 20.9. So this is about 20.9. Now the second thing asks me to find the area of this shape. Now to do that, I need to think about what kind of shape this is. And I notice that both the top and the bottom are horizontal segments. That means they're parallel. These other two sides are not parallel. I can see that this one has a negative slope, whereas this one has a positive slope. They're definitely not parallel. So if it has one pair of parallel sides, it's a trapezoid. And my area formula for a trapezoid says to take 1/2 the height of the trapezoid, which is the distance between the bases. So this is distance between base 1 and base 2. And I'm going to take 1/2 the height and I'll multiply it by the sum of the bases. So the base lengths added together. Now if I look at my picture, I can see that this is going to be maybe base 1 right here. This right here would be base 2. But now I need to know how far apart are those two segments. And it's not going to be this length, and it's not going to be this length, because neither one of those are actually going like straight across from one side to the other. If I'm going to go straight across from one side to the other, I'm going to go along a path that's perpendicular to both of them. And so that would look like maybe going along this path, so that it's perpendicular to that and perpendicular to that. And the nice thing about that is we can actually just kind of count the boxes, because to get from here up to here, I'm going vertically, which means I can count 1, 2, 3, 4, 5 units. So the height is going to be a length of 5, or a distance of 5. So now when it comes time to find my area, I'll take 1/2 of 5 times 7 plus 3. So that's half of 5 times 10, which is half of 50, which is an area of 25.